So this is going to be the homework for tonight, the mole-to-mole conversions. So for the first one, we have a reaction between aluminum bromide and chlorine. Now, first thing we want to do is write out a balanced reaction, so that way we know what we're working with. So for the reaction between aluminum bromide and chlorine, what we end up with is 2 moles AlCl3 and 3Br2, with this being a 3 and this being a 2. So when we have this, what we see is these coefficients are actually the mole-to-mole ratios between these. So in the question, we're asked how many moles of aluminum chloride will you end up with if you start with 6 moles of aluminum bromide. So the two things that we're comparing here are this and this. So by knowing that piece of information, we should be able to create a for every statement. So for every 2 moles of AlBr3, there are 2 moles of AlCl3. So this is going to be the generic for every statement based off of this reaction, because the coefficients here and here tell us what the relationship is. So in the question, it's asking for 6 moles of aluminum bromide. So this should be 6 moles. So here we have a factor of multiplying by 3. Whatever we do to that side, we have to do to this side as well. So what we end up with is 6 for the aluminum chloride as well. And if you read the question, how many moles of aluminum chloride? That's going to be our answer. So the answer is 6 moles of aluminum chloride. So this is going to be our second question. In a reaction between sodium phosphate and calcium chloride, how many moles of sodium phosphate do you need to end up with 12 moles of sodium chloride? So the reaction that we're worried about is sodium phosphate and calcium chloride. So let's write out a balanced reaction for it. So this would be our balanced reaction between sodium phosphate and calcium chloride. Once again, these coefficients that are there, this is what the mole-to-mole ratio would be. So let's see the question again. How many moles of sodium phosphate would you need to end up with 12 moles of sodium chloride? So what we're looking at are these two molecules and the relationship between them. So first thing, we're going to see for every statement. So for every 2 moles Na3PO4, there are 6 moles NaCl. So if that's the case, the question is asking how many moles of sodium phosphate do you need to end up with 12 moles of sodium chloride. So it's telling us this should be 12, which means that we're multiplying by 2. So we need to do that here, which means that we would need 4 moles of Na3PO4. And this should be the answer. So for the next one, in a reaction between aluminum and iron 2 oxide, we have the balanced reaction written out. How many moles of iron would you get from 2 moles of aluminum? So in this case, let's write out the generic based off the ones that we're comparing. And this one should be pretty obvious right now, but let's write it out. For every 2 moles aluminum, there are 3 moles Fe. And the question is basically asking you the same exact thing as the generic formula that we're writing out. So it's just 3 moles Fe as the answer. Number 4, we have how many moles for zinc nitrate would you get from 6 moles? So the question is written out in a backwards way. So the actual reaction is between silver nitrate and zinc chloride, which is what is written out. And now the question is asking to compare zinc nitrate and silver nitrate. When you have 6 moles of silver nitrate, what do you have for the zinc nitrate? So for the generic for every statement, what we see is for every 2 moles of AgNO2, we have 1 mole zinc nitrate. So what that means is that if this zinc nitrate is 6 moles, or I take that back, if the silver nitrate is 6 moles, you're multiplying by 3. What you would do to this side is also multiply by 3. What you end up with is 3 moles of the zinc nitrate. So we have the number 5 reaction written out between sodium and hydrogen and balanced. We're comparing sodium hydride to hydrogen. And what it's saying is the number of moles of hydrogen as being 3, which means multiplying by 3. What's the moles of sodium hydride? So we're going to multiply that by 3, and we end up with 6 moles of NaH. And for the last one, in a reaction between hydrogen bromide and aluminum hydroxide, how many moles of aluminum bromide are made from 9 moles of hydrogen bromide? So we have the generic for every statement, 3 moles hydrogen bromide, there are 1 mole of aluminum bromide. So if there's 9 here, we're multiplying by 3, the factor. We got to multiply by 3 on this side, which means we end up with a total of 3 moles of aluminum bromide.